For the next few problems, we are to integrate the ones that we can. That implies that there may be one or more problems that we don't know how to integrate or can't be integrated at all. Can we do this one? Let's think about it. This is the integral of x minus 1 to the 1/2 power dx. Perhaps we can do u substitution. Let's think about that. If so, u would be what we have on the inside here. So u would be x minus 1. U prime, of course, would just be 1, so we can really ignore that. But rewriting with u instead of x minus 1, we would have the integral of u to the 1/2 power. Instead of dx, we will write du over u prime, which in this case is just du. We should be able to integrate this using the power rule of integration. So we're going to have 1/2 in the front. No. We are going to increase the exponent by 1. So I'm adding 2 over 2. So this is going to give me u to the 3 over 2 power. And then I divide by my new exponent. But dividing by a fraction is the same as multiplying by the reciprocal. So I'm going to end up with 2/3 right here, plus c. And putting x minus 1 back in for u, I have 2/3 x minus 1 to the 3/2 power plus c. So we were indeed able to do A. Can we do part B? Unclear. Let's give it a shot. First, if I were to attempt to do this, I would rewrite this a bit. So I have x times x minus 1 to the 1/2 power dx. Next, I would think to myself, u substitution. Let's let u equal the stuff inside of the parentheses. So u will be x minus 1, which means that u prime will be 1. Simple. Let's make that substitution. So I have the integral of x times u to the 1/2 power. Instead of dx, I will write du over u prime, but u prime is 1, so I don't need to write anything more. I have this. Right now I'm worried because I have this extra x. I didn't have an x in the denominator that would cancel this out. So what do I do? What do I do? Maybe this is one of those ones that's impossible. Don't be so hasty. Slow down. We have this expression that relates u and x. I would love to get rid of this x somehow. Let's solve this expression for x. So if I add 1 to both sides, that will give me u plus 1 is equal to x. Or in other words, x is equal to u plus 1. So let's replace x with u plus 1. We will need parentheses right here, so be careful. Squeeze it in. So I have, whoops, u plus 1. Brilliant. Now I have only u. But can we solve this? What if we do the distributive property with u to the 1/2 power? Keep in mind that u is the same thing as u to the 1 power. So when you multiply with like bases, you add the exponents. So if I do the distributive property, I'm going to have u to the, and then 1 plus 1/2 is 3/2. So I will have u to the 3/2 power. Then of course, u to the 1/2 power times 1 is just u to the 1/2 power. So we can integrate term by term. Looking at the first term, let me write down my u. I need to increase this power by 1. So in my mind, I'm thinking I'm going to add 2 over 2. So that's going to be 5 halves. So I have u to the 5 halves power. Then I need to divide by my brand new exponent. Dividing by 5 over 2 is the same as multiplying by 2 over 5. Let's do the same thing with the second term. Here is my u. I need to add 1 to this exponent. So I'm adding 2 over 2. So that's 3 over 2. And then I divide by my new exponent. Dividing by 3 over 2 is the same as multiplying by 2 over 3. And then I will have the plus c. Putting x minus 1 back in for u gives us the final answer. For part C, the degree of the numerator and denominator are both 1, so this definitely will not be an inverse trig situation. Let's just get started and see if u substitution will somehow work out. I'm going to start by rewriting this a tad. So I have x over, and then in the denominator I will have x minus 1 to the 1/2 power. If u substitution is to work at all, then u will be x minus 1, which means that u prime is equal to 1. A whole lot of nothing. Let's go ahead and make the substitution and see kind of what happens. So I'm going to have the integral of x over u to the 1/2 power. Instead of dx, I write du over u prime, but u prime is 1, so I don't need to write that. I do not like the fact that I have an x remaining here, but it's not a big deal because I can use the relationship between u and x to replace this. So let's solve for x by adding 1 to both sides. So I will have u plus 1 is equal to x. In other words, x is equal to u plus 1. So I'm going to erase this x and put u plus 1 in its place. Now, can I solve this somehow is the remaining question. Perhaps we can use the a plus b over c rule. Do you know what that is? I can rewrite this as a over c plus b over c. So I have that same situation here. So I should be able to rewrite this as 2 separate fractions. So I will have the integral of u over u to the 1/2 power plus 1 over u to the 1/2 power. I'm going to rewrite this slightly by subtracting. So in the numerator here I have u to the 1 power. When you divide with like bases, you subtract the exponents. So I need to do 1 minus 1/2. That's u to the 1/2 power. And of course, 1 over u to the 1/2 power is simply u to the negative 1/2 power. We should be able to integrate this term by term. So let's start by bringing down a u. I need to increase this power by 1. So I'm adding 2 over 2, so that'll be 3 over 2. I need to divide by 3 over 2, which is the same thing as multiplying by 2/3. And then for the next one, I'm putting my u. I need to increase this by 1. So adding 2 over 2 gives me positive 1/2. And then dividing by my new exponent, dividing by 1/2 is the same as multiplying by 2. And then constant of integration. Replacing u with x minus 1 gives us the final answer. Let's do 3 more. For number 50, part A, I'm noticing that the degree of the denominator beats the degree of the numerator by 4. So that indicates that probably this is going to be an inverse trig function, and specifically it's reminding me of the arctangent rule because there is no square root and it is a plus. Let's take a closer look at this arctangent rule. All right, I see the u squared, so I need something squared right here. So I'm going to rewrite this with parentheses. So I can do that by writing 1 over 1 plus parentheses squared. Inside of the parentheses would be x squared. All right, this is the same thing. That means when I do my u substitution, u will have to be x squared, which means that u prime should be 2x. And the a value would be 1 because that's the square root of the constant. Let's go ahead and do the substitution. So that's going to give me the integral of 1 over 1 plus u squared. Instead of dx, I'm going to put du divided by u prime. U prime is 2x. So I have this. I'm a little concerned because this will not cancel out anything. Can I solve this by substituting something for x, maybe? I don't know. I'm pretty worried. If I try to solve this for x, I get more problems because I have to take the square root of both sides, and that's going to give me x is equal to plus or minus the square root of u. What? How can I do a plus or minus? And even if I did that, it's still, I can't see how I could possibly integrate. So this one cannot be done. We have this 2x. Really the extra x is the problem. There is no way to get rid of it. So this is a big old no can do. They did say integrate the ones you can, so we shouldn't be surprised if some of them cannot be integrated. So let's try this one. This one looks suspiciously similar to A. The only difference is we do have an extra x, which may end up helping us out. So I'm actually going to do the same exact steps. Maybe I'll do it more quickly because you've already seen them once. I'm going to rewrite this as x over 1 plus. I'm going to write this as parentheses squared, and inside of here I will have x squared, because x squared squared is the same as x to the 4th power. U substitution. So the u would equal this x squared, which means that u prime will equal 2x. The a value should equal 1 because it is the square root of the constant. If we make that substitution, I have x over 1 plus u squared. Instead of dx, I will write du over u prime, which is 2x. But this time, haha, I have x in the denominator and x in the numerator. These cancel out nicely. The 2 in the denominator will come out to the front as a 1/2. And I'm left with 1/2 times the integral of 1 over 1 plus u squared du. This is now a perfect match for the arctangent rule. So let's use this to integrate. I see a 1 over a in the front. So normally I would write 1 over a, but a is 1. So that would be 1 over 1. I don't need that. That's silly. So I'm going to move on to arctangent u over a. But this time I won't be fooled. Arctangent of u over a. A is 1, so it's just going to be u. And in fact, while I'm at it, can we go ahead and just do the substitution back? So instead of u, let's just go ahead and put x squared. Save a step. So I have arctangent u, which is arctangent x squared, plus c. What am I forgetting? Well, that's the rule, but we did have this extra 1/2 way out in the front of the integral. That is still there, so I'm going to still bring that down. So this is the final answer. Let's do one more. For part C, I'm noticing that the degree of the denominator beats the degree of the numerator, but only by 1. It doesn't beat by 2 or more. That indicates that this will probably not be an inverse trig function. So let's approach this as a simple u substitution. And in fact, let's let the entire denominator be u. So we will let u equal 1 plus x to the 4th power. In that case, u prime will equal 4x to the 3rd power. When we do this u substitution, we have x to the 3rd power over u, because the entire denominator is u. Instead of dx, we will write du over u prime, which is 4x to the 3rd power. Oh, looky here. We have x to the 3rd power in the top and x to the 3rd power in the bottom. These will cancel each other out. The 4 in the denominator will come out to the front as a 1/4. So we have 1/4 times the integral of 1 over u du. So the integral of 1 over u, this is a memorized rule. The integral of 1 over u is natural log u. So I'm going to take this part of it and I'm going to replace it with natural log absolute value of u plus c. And we've got the 1/4 out in the front, so I still will have that. So this is almost the answer. I'm just going to substitute 1 plus x to the 4th power back in for the u. So that is going to give me 1/4 times the natural log of the absolute value of 1 plus x to the 4th power plus c. So this is the final answer. Can anyone guess why I don't need the absolute value symbols anymore? Well, x to the 4th power, that's an even power, so this will always be positive. And then I'm adding a positive 1, so this will be positive on the inside no matter what. So we do not need the absolute value to guarantee that this is positive. It's fine if you keep the absolute value, but I'm just letting you know why we don't need them.